Thanks to the data that we've already seeded, we have some one-to-one relationships in our database, so we can go ahead and perform some queries. Most of what you've already learned about querying relationship applies to one-to-one relationships as well. In fact, all of the means of getting related data, eager loading with include, projections, explicit loading, and lazy loading, can be used with one-to-one relationships. Querying across one-to-one relationships is pretty straightforward. You can query for one or more books and include or project a cover to bring back graphs of books with covers. Here I'm getting all of the books, and some have covers and some don't. Another difference is that when I want to drill into the design ideas for those covers, I don't need to iterate through those covers because at most there will only ever be one. So I can just drill right into it, as I'm doing in this logic, to write out the book title along with its design ideas. But we know there are books without covers, so I do have to check to see if the cover is null or not, and either printing out no cover yet or the design ideas property. The C# syntax I'm using here is pretty terse. In case it's unfamiliar, I'm using the C# conditional operator. It's like an if statement, but uses the question mark after the condition, and then a colon between the true and false responses. And here's the output from the method. First, the query for books with a left join for covers. You've seen a number of these left joins already, and I'd want to make sure that you know what it means in a SQL query. What it's doing is making sure that you get all of the rows on what's thought of as the left side of the query, so that's all of the book rows, whether or not they have a connection to a cover in the dependent table. And after the query, there's the list of books where some have a cover description and the others say no cover yet. Since you've seen plenty of SQL queries and proof of their results, I'll just show you some variations quickly without actually running them. But all of these queries can be found in the sample code. First is the simple include that you just saw. Next, I'm only retrieving books that have covers, and I'm including their covers. So I'm filtering on books whose cover property isn't null. Following that, I'm getting only the books that don't have covers yet, which is pretty useful information if I need to know for which books I need to start getting covers into production. Next is an example of using a projection where all I'm getting back is an anonymous type with a title and cover design ideas for any book that has a cover already. Notice that the select statement is after the where statement. Once I've called select, it's only returning the anonymous type, not the book, so I wouldn't be able to filter on any of the book properties. So I have to start by filtering on the book properties, and then I can express the projection. There are a lot of variations, as there are with the other relationship types. I'm going to take this a step or maybe two further. We have a lot of connected data now in our system. So I'm going to run a type of query you might want for a report. I'll seek out one of the authors, list all of their books, along with any covers for those books, and also see what artists, if any, have been contracted to work on those covers. When you first learned about includes earlier in this course, I mentioned the then include method. That's what you can use to go deeper and deeper into a graph. There was something else I talked about then as well. When you pile on the includes in a single query, you should keep an eye on its performance. It might be a lot of work for EF Core to construct the SQL, or if you've got a lot of data coming back and you're change tracking the results, it could be a lot of work to not just create the state information for the change tracking objects, but also get all of the details of the relationships, which is something else the change tracker keeps track of. In my case, this query will be for a report, so I will definitely make this a no tracking query to avoid paying the price for all that change tracking. And just to be sure this query is clear, I'm querying the authors, including all of the books for each author. Then for each of those books, I'm including its cover. And then for each of those covers, I'm including any artists working on the cover. At the end, with the first or default method, I'm filtering this down to only request this graph for the author whose ID is 4. When I run this, first you see there's a big query to pull all of the requested data from the relevant tables. And as a non-DBA myself, I would like to say that I have at least learned that just because a query looks complicated to my eye, it might be simple for the database to work out. So I've learned not to make assumptions just based on what the query looks like to me. And here's the output. There's the author, Ursula K. Le Guin, and the only one of her books in our database, The Left Hand of Darkness, along with its design ideas and the artist that's been assigned to work on the cover. While I focused on starting with a book end of this one-to-one relationship in these queries, you can absolutely start on the dependent end if you prefer. For example, if you want to look at what covers are in production, you can then bring along their book information and even the author information for the book. Now let's begin to build up one-to-one relationships between covers and books. As with the other relationship types, adding a one-to-one relationship could have different meanings. You could be adding both ends of the relationship all at once. So in this first method, I've created a new book with a new cover, and remember, we also have to identify which author is writing this book. So I'm adding another one of my mom's books here, the one which was nominated for a Pulitzer Prize. And that's not something I'm making up for the course. It is the truth. The book is called Call Me Ishtar, and I'll just use her author ID, which is 1. Then I'll set the book's cover property to a new cover. When I call Save Changes, the behavior is the same as you saw when inserting an author with a book. EFCore first sends an insert statement for the book, then it takes the new book ID, integrates it into the insert command for the new cover, setting it to the value of the book ID foreign key. So that's pretty simple, and not really anything you haven't seen before. Given that it's possible to have a book that does not yet have a cover, you could add a cover to an existing book, and that might be happening with a book object that's already in memory. So here, I've queried for one of the books that doesn't have a cover yet, and I'm setting its cover property to a new cover. It's not really a big deal. And thanks to the foreign key, I can always just create a new cover and set its book ID to the proper value. One thing you have to really watch out for with a one-to-one relationship is accidentally attempting to replace the dependent end. If you have a cover attached to a book, and then you tie the book to a different cover, what happens to the original cover? Remember that a cover must be attached to a book, and only one cover can be attached to any book. Let's see what EFCore does. If EFCore is not tracking the original cover, for example, here I'm just using find to get the book, and this book, The Never, whose book ID is 5, does have a cover associated with it, as you can see in this view of the table. When I set a new cover to this book, EFCore will just send an insert method for the new cover, and the database will throw an error because of the unique foreign key requirement. I can't add a second cover with a book ID of 5. So this is another scenario where understanding the behavior is really important. It's much better to let your code protect you rather than having to deal with errors thrown from the database. So perhaps with one-to-one relationships, when you anticipate this need, then make sure any dependent for a book is also in memory, and then handle the logic more explicitly. For example, here I'm getting a book and including its cover. Now there's no guarantee there's going to be a cover there, but in this case, this book does have a cover. If I just switch to the new cover, let's see what the change tracker thinks about that. Because EFCore is tracking the book and now the cover as well, and it's aware of the data model and the unique index, it's going to send a delete command for the original cover, as well as the insert command for the new cover. So in this case, I'm replacing the cover, but I'm not really doing that explicitly. And if somebody else came along and was reading that code, they may not understand that behavior. So if you want to have more control and more readable and maintainable code, then maybe you'll do something more like this. Here, after I retrieve a book and include cover, I check to see if there really is a cover. And if there is, I have a bunch of options, but the path I'm choosing is to apply whatever info that I wanted as an edit to the existing cover. But you have to understand that that cover might have other information in it or attached to it, such as artists. If there isn't a cover, then you can just create a new one and set it to the book's cover property and then call Save Changes. Or maybe you would inform the person using your application, hey, there's already a cover attached to this book, and here are its details. Do you want to edit it? Do you want to replace it? Or maybe just leave it alone? These are more architectural decisions, really understanding what your business rules are and what kind of logic you want to apply. But before you can make those decisions, it's really important to understand the behavior of the tools that you're using.